students, today we will see electric flux. In our previous video we have already seen the electric field lines and electric field intensity. If I am drawing the electric field lines, it is always appearing from positive charge to negative charge. Now in this region you are seeing the electric field lines which are appearing is more, which means it has a strong electric field. In this region you are seeing the electric field lines are less, which means it has a weak electric field. Now what we will do, we simply put any surface, any square surface in this particular region like this, any other square surface which will is small in this particular region. Okay, so what will happen, just see this surface and the lines are passing through this surface. And how many lines are passing from this surface is 1, 2, 3, 4, 5. And in this surface, how many lines are passing? 1, 2, 3. Okay, so what we can say in terms of electric flux is the quantity which are in terms of electric field lines and linked with any surface which are placed in electric field. Okay, it is a quantity which are in terms of electric field. I'm just showing by sign electric field, which is linked with electric field linked with any area, any surface area, any surface or any particular area. Okay, so suppose just in mathematical language, suppose we have one basket and there is 2 banana, right? So one basket is containing 2 banana. If there is another one basket and it also containing 2 bananas, and if we join the both baskets, what will happen? Now the basket will contain 4 banana. How we will find it? We just simply multiply the quantity of bananas with the quantity of baskets. So it is the particular region, particular surface, it has area, right? It has area, and these are the lines, electric field lines. Okay, and this area is working, this particular region is surface is working as a basket, and these lines are working as a bananas. So what we have done, we simply multiply area with the electric field lines, right? So in other language, what we can say, I'm just rubbing it, the scalar multiplication of area of any surface and electric field lines are called electric flux. Okay, which we have denoted by phi. This is the sign of electric flux. Okay, now it is the scalar multiplication. Why it is scalar multiplication? Because electric field has direction, and if you will think that area is a scalar quantity, no, area is a vector quantity. So we simply put it like E A cos theta. Why we are taking cos theta? Because these electric field lines are appearing. Suppose this is the surface and the lines will always appear in perpendicular direction. This is the perpendicular, this is the line which are appearing in perpendicular. Suppose I have just put it and towards the eyes. Suppose I have put it and now I'm seeing from this direction, then it will appear in the perpendicular to this surface. If I'm putting it like this, now I'm changing the position of the surface and now I'm seeing like this, so the lines will appear in this direction. Got it? It always appear to perpendicular to the surface towards the eyes. So EA cos theta. If we will put 0, then what we will get? EA. If we will 180, then we will get minus EA. That's clear? Now just note it down. Now I'm going to rub it. This is the basic expression of flux, electric flux, in terms of electric field lines and area. Now, if the area of any surface is perpendicular to the electric field lines, this is the area and lines are appearing like this. The both are, perpendicular not. Both are parallel to each other. Then what will happen? If the area and electric field lines both are parallel to each other, then the value of theta will be 0. So the value of phi will be EA cos 0, and the value of cos 0 is 1. So simply we will get phi EA. Now if we will see in this direction, now we are seeing from this direction. So what will happen? Then the value of theta become 180, and what we will get, the phi will be minus EA, because cos 180 is minus 1. Now now we have placed any plate like this. This is any plate, and now the line will appearing in this direction, like perpendicular to the plate. Perpendicular to the plate. It is like this, perpendicular to the plate. The area and electric field is perpendicular to each other. So what will happen? Then the value of theta become 90 degree, and the value of phi EA, that is vector quantity, just put it like this, cos 90, and the value of cos 90 is 0, so the phi will become 0. This is the very simple concept. Okay, now any closed surface, if we will talk about any closed surface, suppose this is any closed surface. Okay, now the electric field lines are appearing in the surface. Suppose 10 lines are appearing in the surface. 10 number of lines are appearing in this surface, and the charge inside the closed surface is 0. So what will happen? This 10 line will appear and will come out from other side of the surface. In this case, the total flux will be, the phi will be 0. Clear? In this case, the phi will be 0 if there is no charge inside any closed body. Now I'm going to rub it, just take a screenshot. This was the first condition which I have just shown you. Now the second condition will be, suppose this is surface and lines are appearing, and the surface has contained positive Q charge, positive charge inside. Then what will happen? The value of flux will be greater than 0. You always get the value of flux will be greater than 0. In third condition, if closed surface is containing minus Q charge, minus q charge, then what will happen in this case? The phi will become less than 0. These are the three conditions of electric flux. I hope it is understand. It is so electric flux, if we will denote in a mathematical form, then what we will write it? This is the sign of flux, that is phi e. Because it is in electric field, we are simply putting here E, phi e, and the summation of that integration sign will show the summation of E into dA, where E is the electric field and dA is the area which are placed, any surface area which are placed in an electric field, and the surface will be closed. Why this is the summation of EDA? Because this is the surface and the flux is linked with this surface. It will link this with this surface, with this surface, with this surface. So this is the summation of the flux which is linked with the all surfaces. So this is the simply notation of the electric flux. Now we will see the Gauss theorem. So Gauss theorem has given by Mr. Gauss. So what he said, this is very important theory. This is the first equation of Maxwell, and the Maxwell is the equation. It has 4 equations. By this, all 4 equations will helpful to understand the all theory of electric and magnetic fields, which is related to electric and magnetic fields. We will discuss further. Now we have just first equation, which is Gauss theorem. So according to Gauss theorem, they said to finding the electric flux, the body should be closed. The body should be closed, and in any closed surface, the flux is linked with the charge which is inside the body. Suppose there is another body and these are the charges which are in this particular region. So the flux will be always linked because of these charges, not with these charges. The charges which are placed in outside the body, they will not useful to get the flux, electric flux. Okay, suppose another body and the charge are placed here and there is no charge inside the body, so we simply will tell that the total flux will be 0 because there is no charge. Okay, so according to Gauss, what he has said, if any surface is placed in electric field, so the flux linked with the surface will be 1 by epsilon naught of the charge which is inside the body. Inside the body, the charge which is inside the body is 1 by epsilon naught times of that charge is become the flux which is linked with this particular body. So in mathematical, how we can write it? Phi E equal to Q. Suppose there is one charge, that is Q, which is inside the body, Q, and that is 1 by epsilon naught times. So that will become Q upon epsilon naught. This is the Gauss theorem. If we will compare both the equation, then how we can write it? I'm just rubbing it, just note down or take a screenshot. In combined form, we will write it phi, sorry, this is phi, this is also phi. If we will equate the equation, it will become close integration of EdA equal to Q upon epsilon naught. This is the Gauss theorem. This has a simple law. Now we will see the proof of this theorem. Okay. For Gauss theorem. So in mathematical expression we write it closed summation of EdA, that will be equal to Q upon epsilon naught. We should prove it, and that is our LHS side. Suppose this is the closed surface, any plus Q charges placed inside the surface, that is plus Q. Because of Q, that is plus Q, it will outward radiated like this. We are seeing this is the shape of circle. It has radius and we are taking it R. It has some area, particular area in this point, that is a very small area of the whole surface, that is dA, a small part. Now in this we just simply put the value of P. We know the expression of electric field, that is 1 upon 4 pi epsilon naught Q, because of this Q charge, upon the value, the distance from this point to this point is R. So we will simply put the R square. That is the expression of electric field. We simply put this expression ED 1 by 4 pi epsilon naught, this is E, and that will be Q upon R square. The whole expression is for E, and this is dA. Now you are seeing here the epsilon will be distributed in all the parts in this closed surface. So we can take it as a constant. It has constant value. The charge is also divided in the whole particular area. So this is also a constant value, and R, if we are taking R measuring, if it is R, so this distance from, if we will take from this point to this point, this will be also R, this will be also R, so this will be also constant. So we simply make it outside the integration, that will be 1 by 4 pi epsilon naught Q upon R square. Now what we have, integration of dA. This is the simple, a very small part. If in this particular region, so it has some small part dA, it has some small part dA, it has some small part dA. So this will be the summation of all dA. So what we simply put, we simply put the area of sphere, that is 4 pi R square, where 4 pi will be cancelled out, R square will be cancelled out. So what we will get, we simply get Q upon epsilon naught, that is RHS side. So here LHS equal to RHS. This is the proof of Gauss theorem. Okay.